Hello, and welcome to just a quick run-through of Kerbal Space Program. We're just going to be going over the basics, just some controls, and how to start out the game. So we're assuming you've already launched the game. I'm running in 1280 by 720 display resolution, but you can turn it down if it's not running very well. I've got all my settings turned down just for the recording. Normally I have them at about medium. Yeah, I just want to give you guys a rundown of what's going on here. Alright, so what you're going to want to do is you're going to want to start out by hitting Start Game. And that'll just take you over to the list of saved games. You can do different saves for different scenarios or whatever you want to do. What we're going to do here is we're just going to start a new one for now. But you can definitely resume. So I'm just going to start a new game here. Doesn't really matter what it's called, and I'm going to start new, and it's going to take me directly to my space center. Now if you're using an older computer, some of these buildings may be blacked out. It shouldn't be too much of a problem though, it's just an issue with the textures. Hopefully it works out for you. Just a quick rundown of what these buildings are. This is the space plane hangar. This is where you can build aeroplanes, which are slightly different from rockets in that they are horizontal takeoff and generally do not use oxidizer, while they do still use fuel though. However, if you build a space plane with rocket fuel and rockets attached, it will still launch. Alternately, what you can do is if you have a rocket that's too big for the launch pad, you can actually drag the ship file in the KSP folder into the spaceplane folder, and that'll allow you to launch it off of the runway. Clicking on the spaceplane hangar will take you inside the spaceplane hangar to build your spaceplane. Clicking on the runway allows you to select a spaceplane to launch if you have any saved. You can also choose from the example spaceplanes. Same idea for the vehicle assembly building. This is where you're going to build your rockets. It's optimized for vertical ship building, whereas this is optimized for horizontal ship building. The vehicle assembly building is also quite a bit larger, so I highly recommend that you try and build any rockets there and not in the spaceplane hangar. And the launch pad is where you're going to be launching most of your rockets. This is a relatively small pad. Sometimes larger rockets can collide with the launch tower itself. Hopefully that's not too much of a problem for you. Same idea here, you can click on the launch pad and select any saved vehicles without having to open them again in the vehicle assembly building. And finally we have the tracking station. If you click on this, it'll show you a map of your solar system, as well as any flights you may currently have in progress, whether they're orbiting or interplanetary or wherever they may be. If a rocket crashes, if a mission crashes and fails, then it will no longer show up in the tracking station, except possibly as debris. And you can go into the settings and change how much debris will stick around. There is a limit, obviously. If you run 100 missions and they all fail, and each mission had 50 parts, you're going to end up with 5,000 debris laying around, and you definitely don't want that. So I recommend turning it down to maybe like 25 or a reasonable number like that. So let's just go into the tracking station and take a look at our solar system. Alright, so you start out on the planet Kerbin, which is Earth-like, slightly smaller, slightly lower gravity and thinner atmosphere than Earth. It has, if we zoom out, 2 moons. The Mun, or moon, which is at a 0 degree inclination, 11,400 kilometer orbit around the planet Kerbin. And then there is also Minimus, which is in a 46,400 kilometer orbit, which is, I believe, slightly, no, it's circular. However, it is inclined to, I believe, 16 degrees, but don't quote me on that. You also have the sun that these planets are orbiting, as well as a few other planets. You've got Moho, Eve, Kerbin, Duna, Jool, and finally Ilu. And each of these planets, well, not each of them, but most of them have a moon of their own. Some of them don't. That's just really up to you to explore, look at what planets have what. So the interior planets generally don't have moons. There's Gilly, very small eccentric orbit moon, quite a bit of inclination. And yeah, Minmus, Moon, Kerbin, Duna, which is sort of like Mars. It also has a moon called Ike. And we have, oh, Dre. I forgot about Dre. Dre is an asteroid. Pretty small asteroid. Eventually, they plan on having a full asteroid belt. But right now we've got Dre, which actually is small enough that you can, while in a EVA, you can take off with just a jetpack. Jool is a gas giant. I don't recommend trying to land there. It has quite a few moons, similar to Jupiter, as you can see. Lathe, Vol, Tylo, Bop, and Pol. And then, last but not least, we have Ilu, which is sort of the oddball planet. It's got a highly eccentric orbit, no moons. It's pretty hard to get to. It's an ice planet. It's got this weird cracked sort of look to it. It's pretty cool. Cool to explore, hard to get to. It's sort of your final destination, if you want to say. It's the ultimate mission. Alright, so let's go back to the Space Center and start out with the basics of how to build your rockets. Now, the vehicle assembly building, once you click on it, will give you a view of the VAB, and you can see down the runway to the launch tower. On the left, you have all your parts, and the title of your craft, and a few other buttons that I will show you in a moment. Now, the first step to building any craft is to choose the command module. Now, ignore a few of these command modules. I've got some extra mods installed that are not included with the game, so just ignore, I believe, these 4 here. So, yeah. But we're going to go with the basics, and we're going to put on a Mark 1 command pod, which has 1 crew and a pretty low mass. This is just a really good place to start for anybody, just to get the basics of what's going on. So we're going to click that, and it'll start us out with our little command module. Now, the controls in the VAB are pretty simple. Right click will let you orbit. A left click will let you drag items. The scroll wheel zooms vertically. Holding down the scroll wheel, if you have that, lets you zoom in and out. But you can also hold shift and do the scroll bar. The scroll wheel will also let you zoom in and out, as well as, I believe, the numpad plus and minus. I'm on a laptop right now, so I don't really have a numpad. But if you do have a numpad, there are some numpad controls that you can look up that can be pretty useful, as I understand. So, building our rocket. There's a few essential items that aren't entirely necessary, but they can be really helpful. And they are under the Control tab. So, the first thing we want to add, however, is a parachute. So if you go into the Utility tab and go to the parachute, the Mark 16 parachute, it is the correct size for placement on top of our current capsule. There are some other parachutes, but they're the wrong size. and it would not work very well. Now, since this is our final stage, upon re-entry we want to just have our command capsule and our parachute. So we need a way of detaching anything else that might come below this. So in the structural tab, you will find a TR-18A stack decoupler. This has a small explosive charge that will separate anything attached to it. Now notice there's a little red arrow on this decoupler, and that indicates what piece will be decoupled. So when I activate this decoupler, it means that the command module and anything attached to it is going to separate from the rest of the ship. The separator itself will remain attached to anything on the other end of it. So if we wanted to keep the decoupler attached to our command module, we could use our W, A, S, and D keys to rotate it and flip it upside down. However, we don't want to do that right now. We want our final stage to just be the command module and the parachute. So, next we need a way of getting up in the air. So, first we're going to add some controls. Now, in the control tab, we have a couple different items. A few of these, again, are from some of the mods I have installed. These three here. Just ignore those. And there's also a nose cone for space planes. Don't worry about that right now. What we want is the advanced SAS module. This lets us lock onto a certain heading and will basically negate any rotation the ship may have. So we're going to attach that right there. And that'll allow us to basically switch on an autopilot that at least helps us stay in one direction. Now, let's go over what some of these buttons down here might be. The first ones we have are these three down here, which are the center of thrust, center of lift, and center of mass. Since we don't have any engines right now, the center of thrust is sort of nowhere. It's just sort of down on the floor pointing in a random direction. Our center of lift is the same. We don't have any lift surfaces. This is more used for space planes, and we want to make sure that its center of gravity and center of lift from the wings are roughly in the same place so that it doesn't tip. Lastly, we have the center of mass, which right now is roughly in the middle of the command module, being the heaviest object on the ship. We don't have to worry about that right now. We just want to get into space. So, let's add some fuel. Now, there are many different sizes of fuel tanks, but the ones we want are probably, for right now, just this. Now, as you can see from the tooltip, this part here holds 360 probably liters of liquid fuel, and it has a mass of 4.5 tons. Right now, the drag doesn't really matter, because the physics engine doesn't really factor it in entirely. There is atmospheric drag, and I'll explain that to you once we take off. But putting a nose cone, for example, on an extra fuel tank doesn't really make too much of a difference to how our ship flies. Now, another important thing is under the impact tolerance, you'll see that it mentions that it is capable of fuel crossfeed. That means that if we took a second one of these and stuck it below the first one, any engine that would be below would be able to feed through this fuel tank out of this one until this one is empty, and then it'll feed through this one. We don't want to do that right now, though. We just want to get this thing up in the air. So, we're going to stick on an engine. Now, there are many different engines, but most importantly, we want to pay attention to the max power and whether or not it has thrust vectoring. Thrust vectoring allows us to use the engine as a sort of directional thruster. It lets us steer in a certain direction more than just a non-vectoring engine, which will just push us in one direction. Since we want to be able to control our vessel once we're in space, it's helpful to have a thrust vectoring engine. Now, there are two engines here that have thrust vectoring that I could use. I'm not going to use this one, however, because its max engine power is only 50, and that's not going to be enough to get this ship off the ground. This is more for landers and smaller vessels, honestly, I really wouldn't use it for much of anything. Maybe you could stick it on a space plane. Right now we're going to use this engine. This engine has a max power of 200, which is lower than this engine, but that's only because it has thrust vectoring. Now, another important item is the specific impulse. As you can see, it says ISP at sea level and in vacuum. And through the different engines, they can be very different. A higher ISP level means that you're going to get more thrust per unit of fuel. It's basically a rating of how fuel efficient they are, where higher values are better. So in this case, we have a ISP at sea level of 320 and an ISP in a vacuum of 370. This means that this engine is more efficient while in space. That doesn't really matter right now. We're just going to stick it on. Now, we could launch this rocket, and it would probably get up into the air. However, we wouldn't have much control over what's going on. So, we're going to add some control surfaces. In the aerodynamics tab, there are many different surfaces that we could use. However, I want a very specific one. On the second page, we have the AV-R8 winglet. This is a good little wing. It's relatively small, but it does gimbal, so we can control the ship. It's not just a static wing like some of the others. Also, it doesn't have a specific direction of lift. If we used, for example, a canard, it would create lift in a certain direction because it's a wing. It's got a camber. And if you have all of your wings lifting in a certain direction, it's going to cause your ship to spin, and we don't want that. We just want to go straight, so we're going to put on a winglet. Now, having one winglet really isn't going to get us anywhere, and it'd also throw off our center of gravity. What we want to do is put on more than one. We could do it manually, but there's an easier way. What we can do is turn on symmetry. Now, you can activate this with the X key. Hitting X will cycle through the different modes of symmetry. And hitting Shift and X goes backwards through the list of symmetry. Now, we may want, let's say, 4 wings. So if we toggle through the symmetry till it says 4, and click, we can attach 4 wings automatically. This also means that these items are part of a symmetry group. So if you control one, you control all 4 in the same way. This isn't really important for wings. However, if we attach landing gear to a space plane, or say illuminators for docking, we want to be able to control all of the illuminators at once, or all of the gear at once. Another button you may notice is the angle snap button. This allows us to attach items either in specific increments of 15 degrees or smoothly anywhere we want to. Since we want to put these on exactly in the middle, we'll use the angle snap. Now we have an engine, fuel, control surfaces, SAS, a decoupler, a command module, and a parachute. Now, if you want to move your vessel to attach more items to the bottom, you can either click the command module and scroll up and move it around, or you can hold Shift and click any item and it'll select your whole vessel. Otherwise, you'll just select that item and it'll pull off. This is a great way to create taller vessels, but right now, we just want this. The last step before takeoff is to make sure that your vessel is supported on the runway, so we need to add stability enhancers. These are just towers that attach to the side of our vessel. They'll detach when we take off, and we'll leave them behind, but they'll hold us from falling to the ground. We only want to put on 2, so let's hold Shift and tap X to cycle backwards through our symmetry modes. Now we only have 2. The final step before taking off is to make sure that our launch stages are correct. Now, basically, when you're flying, you have different stages, and you can detach stages. When all the fuel is gone from this fuel tank, we don't want to haul it around anymore, and we'll want to ignite this decoupler. We'll do that by pressing spacebar in flight, and it'll go through each of these in order. It'll start with 2, then we press space and it'll go to 1. When we press space, it'll go to 0. When we press space for the first time, we want our engine to ignite and our stability enhancers to decouple. As you can see, Kerbal Space Program has already set it up so that this happens automatically, but sometimes on larger ships it can't really figure out what you want it to do, and you'll have to drag these around manually. Now, since these stability enhancers are in a symmetry group, they were listed as one item, and when you clicked on it, they expand. You can click and hold shift and click to select, control and click to select more than one item, and you can drag them around into different symmetry groups. Into different stages. Right now we want them to stay in the first stage, the second stage. The stage labeled 2. So that they decouple and activate as soon as our engine ignites. Then, once our fuel is run out, we'll activate the next stage, which will ignite our decoupler and detach our command module. Finally, once we start descending, we'll ignite the final stage, which will let loose the parachute. As you can see, when I hover over each of these items individually, they highlight on the staging list. If I hover over the stability enhancers, you'll see that their item here highlights. And when I hover over this item here, it'll highlight them in the VAB view. Finally, we want to name our vessel. Let's just call it the Spaceship 1. These buttons up here are important. They allow you to control individual vessels. This button will create a new one. This will load an existing vessel. This will save your current vessel. This will launch. And this will return you to the Space Center. Right now we want to save and then launch. See you at the tower. Hello and welcome to the launch tower. The controls here are slightly different. The scroll wheel lets you zoom in and out. The right mouse button continues to allow you to rotate around your vehicle. And the left mouse button really doesn't do much. Now, the first thing we want to do is to be able to look at and control our vessel. So, by right-clicking on our vessel, we can view details about each of the individual parts. For example, if I right-click on the fuel tank, we can see how much fuel is left in it. We can also press these buttons to turn off the liquid fuel and oxidizer flow. Right-clicking on the decoupler will give us an option to manually decouple it. The engine also allows us... The engine will also allow us to manually activate it, and we can also lock its gimbal, which will basically disable its vectoring ability. To control our vessel, we will use the W, A, S, and D keys. A and D control our yaw. This is the movement of the vessel left or right. Roll is controlled by Q and E. This allows us to rotate our vessel around its central axis. W and S control the pitch. If you want more fine-tuned control over these movements, you can press the caps lock key. This puts you into fine mode, which slows the rotation of each of the individual control surfaces, as well as the vectoring nozzles. I'm going to turn it off for the moment. Finally, we want to be able to enable our SAS module, our autopilot, and lock on the heading of up. Pressing T will do this. And as you can see, the SAS light on our control panel has lit up. Another important control is R, which will enable our RCS thrusters. We didn't add any to this vessel, but I'll show you that in later videos. For now, I'm going to turn it back off. Finally, Shift and Control controls our throttle, which is shown here on this dial on the left. Shift throttles up, and Control throttles down. While you're throttled up, pressing X will instantly throttle you all the way down. This is useful if you need to cut off your engine quickly. You can also stop anywhere along the way. Some engines overheat, and you can only throttle them up to about 80%. This particular engine doesn't have that problem though, and will be able to throttle to 100%. Before you lift off, do not forget to enable your SAS and throttle all the way up to 100. Otherwise, your ship will just fall onto the runway, or angle off randomly and crash right into the ground. After all, this is pretty much just a ballistic missile with a man in it. Speaking of men, we can also look at the interior view of our ship by pressing the IVA button. This shows us what the interior of our ship looks like. We have the same controls, including a radio altimeter. Pressing C will return you to the exterior view. C also enables, there we go. V changes the camera angle between auto, free, and orbital. Once our ship is moving, it'll also enable the chase mode, which puts us directly behind our vessel, so we can see directly where it's going. Right now, we want free, so that we can place the camera wherever we want it. I'm just going to put it here. Now, by pressing the space, I can activate our first stage. This will engage our primary engine and our 2 docking clips. Let's do that right now. Careful, if you don't have your sound turned down in the settings, this can be really loud. Here we go. Now, we can monitor our fuel usage by right-clicking on the fuel tank. As you can see, we're doing pretty well. You can also click the resources button to permanently keep open our resources. As you can see, we're accelerating upwards at a very rapid rate. Because Kerbal Space Program factors in air resistance, this means that throttling up all the way at a low altitude is not necessarily a good idea, since air resistance will waste most of your fuel. So next time we launch, we'll try throttling back a little bit and not wasting so much fuel on launch. Once you get to about 10 kilometers, we're going to start angling over at 90 degrees. This is what's called a gravity turn, and uses our momentum, because the Earth is rotating, to enlarge our orbit in the correct direction. So we're going to keep doing that. Ooh, and it looks like I've run out of fuel. Well, looks like we wasted too much in the lower atmosphere. However, we can still demonstrate many of the important factors of this game. Pressing M will eject you into the planetary view. As you can see, our focus is on our ship. It'll tell you your velocity and your altitude. We can also press this tab to bring back up the nav ball. We can also see that we have 2 debris items back at the launch pad. Those are the structural towers that we decoupled it with at launch. The blue line indicates our current orbit, or path of travel, and we can see that our apoapsis, or the highest point we will reach, is at 70 kilometers and about a minute away. Using right click, we can zoom around our ship. Scroll wheel allows us to scroll in and out. much like in the tracking station. We can also use the arrow keys, or sorry, the comma and period keys to turn on warp. This just accelerates the simulation of time. So if we warp ahead, we can skip the lengthy waiting process of getting to our apoapsis. Normally here, we would angle prograde and thrust forward to circularize our orbit. However, since we're out of fuel, and I haven't explained the nav ball yet, which I will do in a later video, we're just going to descend back into the atmosphere. We don't want to descend like this though, so let's press spacebar again, and we'll activate our next stage, which will blow our decoupler. Now our command module is free. Once we re-enter the atmosphere, we'll press the spacebar again to engage our parachute. Let's fast forward time a little bit and get there. As you can see in this bar here, we've started entering the atmosphere. As it gets denser, air resistance will slow us down more and more. At the moment though, it's so thin that gravity is still accelerating us. Once we enter the thickest part of the atmosphere, we can activate our parachute. At this point, we can also turn off our SAS. As you can see, we're slowing down because of atmospheric drag. And at about 5 kilometers, I'll activate the parachute. The parachute will slow us down further, and once we get low enough, we'll fully deploy and slow us down to about 5 meters per second. There we go. Now we can accelerate forward. As you can see, we're approaching the ocean. At this speed, landing on the ground on a continent wouldn't have been a problem. However, we're about 70 kilometers away from the Space Center. Now that we've splashed down, we can hit escape and end the flight. If we wanted to, we could restart the flight and try our ascent again, this time conserving fuel more wisely. Or we can go to the vehicle assembly building and attempt to improve our design. We can also go to the tracking station and fly a different ship. Right now we're going to go to the Space Center. Because we ended that mission, going into the tracking station will no longer show it on the map, and it is not listed in the flights in progress. If we had achieved a stable orbit, our mission would have been essentially infinite, which means that when we hit escape, we would have had the option to go directly to the Space Center instead of ending the flight. That would leave our vessel in the in the tracking station, orbiting our planet, or wherever else it happens to be. Hopefully that gives you a good idea of the basics of Kerbal Space Program. Thank you for listening.